see other customers that are not in the current result set. Let's take a look. So instead of customers with IDs 1, 3, 5, 6, and so on, we get the customers with IDs 2, 4, and 10. Now, technically, these customers were born before 1990, and they have less than 1,000 points. So if you look here, this first customer was born before 1990, and he has less than 1,000 points. How did I know that? Let me show you a trick that I learned in math. Whenever you have a not operator, you can simplify your expression like this. We apply the not operator to the first condition. People who were born after 1990. How can we negate this condition? Well, the greater than operator becomes less than or equal to. That is the inverse of that condition, right? Now we apply the not to or to negate the or. What do we get? We get and. Finally, apply the not operator on the last condition. People who have more than 1,000 points. When we negate this condition, we get customers with less than or equal to 1,000 points. Now we can remove the not operator to simplify this. We don't need parentheses anymore because we only have two conditions that are combined with an and. Here's the result. As you can see, this is much easier to read and understand. People who were born before this date and they have less than 1,000 points. All right, here's your exercise. From the order items table, get the items for order number 6, where the total price for that item is greater than 30. All right, here's the order items table. In this table, we have these columns: order ID, product ID, quantity, and unit price. If we multiply the quantity by unit price, we can get the total cost of that item. And then we can compare it with 30. So let's go ahead and write this query. Select star from order items, where here we need two conditions. One is for the order, so order underline ID should be 6. And the second condition, we want to calculate the total price. So we get the unit price, multiply it by quantity, and this value should be greater than 30. So as we can see, we can use an arithmetic expression in a where clause. It's not limited to the select clause, okay? Now let's execute this query and see what we get. We should get only one item. That is for product 1. Here the quantity is 4 and unit price is just over $8. So the total price for this item is greater than 30. Hey guys, Mosh here. In case you haven't seen my website yet, head over to codewithmosh.com. This is my coding school where you can find plenty of courses on web and mobile application development. In fact, recently I published a complete SQL course that is about 10 hours long, and it teaches you everything you need to know from the basic to the advanced topics such as database design, security, writing complex queries, transactions, events, and much, much more. These are the topics that every software engineer must master. This YouTube course you've been watching is the first 3 hours of my complete SQL course that is about 10 hours long. So if you want to master SQL and get job ready, I highly encourage you to enroll in my complete SQL course. You can watch it anytime, anywhere, as many times as you want. You can watch it online or download the videos. The course comes with a 30-day money-back guarantee and a certificate of completion that you can add to your resume. The price for this course is $149, but the first 200 students can get it for just over $10. So if you're interested, the link is below this video. In this tutorial, I'm going to show you how to use the in operator in SQL. So as an example, let's say we want to get the customers that are located in Virginia or Florida or Georgia. One way to write this query is like this. So where state equals Virginia, or state equals Georgia, or state equals Florida. Now, people who are new to the SQL language or programming in general find this expression a little bit strange. They ask, Mosh, why can't we write this expression like this? Where state equals Virginia, or Georgia, or Florida. Here's the reason. We use the OR operator to combine multiple conditions. So here we have a condition or an expression more accurately, but on the right side of this OR operator, we have a string. In SQL, we cannot combine a string with a Boolean expression that produces a Boolean value, which can be true or false. So that is why we have to write our query like this. So we have multiple expressions or multiple conditions, and we're combining them using the OR operator, okay? So now if we execute this query, we get these customers here, but there is a shorter and cleaner way to get the same result. Instead of combining multiple conditions using the OR operator, we can use the IN operator. So where state is in, and then in parentheses, we add all the values like Virginia, comma, Florida, comma, Georgia. And the order doesn't matter. This query is exactly equivalent to what we had earlier. But as you can see, it's shorter and easier to understand. So let's execute it. Look, we get the exact same result. Now here we can also use the NOT operator. Let's say we want to get the customers outside of these states. So we can use where state not in this list. Now if we execute this query, we get customers who are located in Colorado, Texas, and so on. So use the IN operator when you want to compare an attribute with a list of values. Now here's your exercise. I want you to write a query to get the products where their quantity in stock equals to one of these values, 49, 38, and 72. So pause the video, do this exercise, and then come back, continue watching. All right, this is pretty easy. So we do a select star to get all the columns from the products table where quantity in stock. In, we use the IN operator to compare this attribute with these values, 49, 38, and 72. Let's execute the query. We get only 2 records because we don't have a product with quantity in stock equal to 72. In this tutorial, we're going to look at the between operator in SQL. So let's say we want to get the customers who have more than 1,000 and less than 3,000 points. One way to write this query is like this, where points greater than 1,000, well, more accurately, greater than or equal to 1,000, and points less than or equal to 3,000. When we execute this query, we get how many? We get 4 people that satisfy this criteria. Now, whenever you're comparing an attribute with a range of values, you can use the between operator, and this makes your code shorter and cleaner. So we can rewrite this expression like this, where points between 1,000 and 3,000. This is exactly equivalent to what we had before. So these range values are also inclusive. That means points is going to be greater than or equal to 1,000 or less than or equal to 3,000. Let's execute the query. We get the exact same result. All right, now as an exercise, I want you to write a query to get the customers that are born between January 1st, 1990 and January 1st, 2000. All right, so we start with select star from customers where birth underline date between. So what matters here is that we can use the between operator for date values as well. It's not limited to using numbers. So where birth date between, now we need to supply 2 date values. So as I told you before, the format for dates is 4 digits for the year, so 1990, 2 digits for the month, and 2 digits for the day. So the birthday should be between this value and, here's the second value, 2000, 0, 1, and 01. Let's execute this query. We get only 3 people who match this criteria. In this tutorial, I'm going to show you how to retrieve rows that match a specific string pattern. For example, let's say we only want to get the customers whose last name start with B. So here in the where clause, we type out where last name. This is where we use the like operator. And right after that, we add a string pattern. So we want to get the customers whose last name start with B. And we have any number of characters after B. So we use the percent sign to indicate any number of characters. We might have one character after B, or no characters, or 10 characters. With this pattern, we get all the customers whose last names start with B. And also, it doesn't matter if it's an uppercase or a lowercase b. So let's execute this query. There you go. So we only have 3 customers whose last names start with B. As another example, let's say we only want to get the customers whose last names start with brush. So we change our pattern to brush %. Now let's execute the query. We only get this one customer here. Now this percent sign doesn't have to be at the end of the pattern. It can be anywhere. For example, let's say we want to search for customers who have a B in their last name, whether it's at the beginning, in the middle, or at the end. So we change our pattern to %B%. This pattern means we can have any number of characters before or after B. Let's execute the query. These are the customers who have a B somewhere in their last name. It doesn't matter if B is at the beginning or in the middle or at the end. Let's look at another example. I want to get all the customers whose last name end with Y. So here's the pattern we use. Let's execute this query, and we have 5 customers whose last name ends with a Y. So this is how we use the percent sign. Now we also have an underscore, and that matches a single character. So with this pattern, we get customers whose last name is exactly 2 characters long. We don't care what the first character is, but the second character should be Y. Let's execute this query. Obviously, we don't have any customers whose last name matches this pattern. But if we change this pattern to 5 underscores, so 1, 2, 3, 4, 5, followed by a Y, we should get these customers. So their last name is exactly 6 characters. We don't care about the first 5 characters, but all of them end with a Y. Now, as another example, we can replace the first underscore with B, and that means we want to get the customers whose last names start with B, and after B, we have exactly 4 characters followed by a Y. Let's execute this query. So we only have 1 customer that matches this pattern. So this is how we use the like operator. We use the percent sign to represent any number of characters and an underscore to represent a single character. Now, this like operator in MySQL is an older operator, but we also have a newer one that is more powerful, and it allows us to search for any string patterns. And that's what I'm going to show you next. All right, here I'm going to give you 2 exercises for the like operator. First, I want you to get the customers whose addresses contain trail or avenue. And next, I want you to get the customers whose phone numbers end with 9. All right, let's get started with the first exercise. So select star from customers where address like. Now here we want to use a search pattern like this. We want to have trail, but trail can be anywhere in the address. So we put a % before and after trail. Next, we should use the OR operator to search for another pattern. Or address like. Let me put this on a new line. That is better. Address like, once again, %, avenue, %. That's it. So let's execute this query. Here is the result. You should get the customers with IDs 2, 9, and 10. If you look at their addresses, all of them have either trail or avenue in their address. Now let's work on the second exercise. We want to get the customers whose phone numbers end with 9. That is pretty easy. So let me change our where clause. Where phone, once again, we use the like operator, add a % followed by a 9. That's all you had to do. Let's execute the query. So here's the result. Customers with IDs 3 and 7. Their phone numbers end with 9. So this is how we use the like operator. And by the way, you can always use the not operator here. Let's say we want to get the customers whose phone numbers don't end with 9. So we simply prefix like with not. Now, if we execute this query one more time, we get all the other customers in the database. In the last tutorial, you learned about the like operator in SQL. So as another example, let's say we want to search for the customers who have the word filled in their last name. So we type out a where clause like this, where last name like percent filled percent. So the word filled can be anywhere in the last name. Let's execute this query. We get only one customer. Beautiful. Now we also have another operator in MySQL that is regexp, which is short for regular expression. And regular expressions are extremely powerful when it comes to searching for strings. So they allow us to search for more complex patterns. Here's an example. If I want to rewrite this last where clause using a regular expression, it looks like this. Where last name regexp. Now here in our string pattern, we don't have to type out the percent signs. We only type out filled. So what we have on line 4 is exactly identical to what we have on line 3. Let's execute this query. We get the same result. Beautiful. Now here in regular expressions, we have additional characters that we don't have when we use the like operator. For example, we can use the caret sign to indicate the beginning of a string. So if I put a caret just before the word filled, that means our last name must start with filled. Obviously, if we execute this query, we don't get anyone that matches this criteria. So we use the caret sign to represent the beginning of a string. We also have a $sign to represent the end of a string. So this pattern means the last name must end with filled. Let's execute this query. We get the same result as before. Now we can also search for multiple words here. For example, let's say we want to find the customers who have the words filled or Mac in their last name. So we use a pipe, a vertical bar, and type out another pattern. Let's execute this query. So here we have two customers. One of them has the word Mac. The other has the word filled in their last name. Now we can take this to the next level. Let's say we want to find the customers who have the words filled or Mac or Rose in their last name. Let's execute the query. We get 3 customers. Beautiful. So we use a pipe or a vertical bar to represent multiple search patterns. Now, as another example, we can change our first search pattern to something like this. Now this pattern means the last name should either start with the word filled, or it should have the word Mac in it, or it should have the word Rose. Let's execute the query. Now we get only 2 customers because our customer with the last name Brushfield doesn't match this pattern. However, if we change our first pattern to filled $sign and execute the query, we get 3 people here, 3 customers. So this is how we can combine multiple special characters when building a complex pattern. Now let's look at another example. Let's say we want to search for customers who have an E in their last name. So these are all the people, all right? Now, let's say we want to make sure that before the letter E, we should either have a G or an I. So this is where we use square brackets. And inside the brackets, we add multiple characters like G, I, M. And that matches any customers who have GE or IE or ME in their last name. So any of these characters can come before E. Now let's execute this query. There you go. We only get 2 customers. In the first example, before E, we have I, which is one of the characters inside the brackets. In the second example, before E, we have a G, which is also another valid character before E. Now, once again, the square brackets don't have to be before E. We could add them after E. So any customers who have E followed by an F or an M or a Q in their last name can be returned with this pattern. Obviously, we don't have anyone in the database. So this is how we use square brackets. Now we can also supply a range of characters. For example, we can have E, and just before E, we want to have any characters from A to H. We don't have to type them out explicitly like A, B, C, D, E, F, G. That's very verbose. So we can type out A to H. And now if you execute this query, we get these 3 people. So let's quickly recap everything you learned about regular expressions in this tutorial. We use a caret to represent the beginning of a string. So beginning. We use a $sign to represent the end of a string. We use a vertical bar or a pipe to represent a logical OR. So we can supply multiple search patterns. We use square brackets to match any single characters listed in the brackets. And finally, we use square brackets with a hyphen to represent a range. So any characters from A to, let's say, F. Now, technically, MySQL supports more special characters, but quite honestly, the ones that I have listed in this tutorial are the ones that you'll be using 90% of the time. So just memorize these and you're good to go. Quite honestly, a lot of beginners find the syntax for regular expressions confusing. So in this video, I'm going to give you 4 exercises that I have carefully designed to help you quickly learn about this syntax. Here's the first exercise. Get the customers whose first names are Elka or Amber. And note that this is Amber with a U. Now for the second exercise, return the customers whose last names end with EY or ON. Here's the third exercise. Get the customers whose last names start with my or it contains SE. And finally, as the last exercise, return the customers whose last names contain B followed by R or U. So go ahead and spend 2 to 3 minutes on this exercise. When you're done, come back, continue watching. All right, let's knock out the first exercise. So we want to get all, there's a C here. Select star from customers where first name, regular expression. And here's our pattern. We want to search for 2 words, either Elka or Amber. Simple as that. Let's execute this query. We should get 2 customers. There you go, Amber and Elka. All right. Now let's knock out the second exercise. So I'm going to delete this. We don't need it anymore. So we want to get the customers. Select star from customers where last name should end with either EY or ON. So in the search pattern, we type out EY followed by a $sign to indicate the end of a string. Then we add a vertical bar to supply the second search pattern. So ON and once again a $sign. Let's execute this query. Actually, I forgot to type out regular expression. There you go. So let's execute this query. And we should get these 4 customers with IDs 1, 3, 5, and 7. The first 3, their last names end with EY. And the last customer, his or her last name ends with ON. All right. Now let's work on the third exercise. So I'm just going to change the regular expression here. We want to get the customers whose last name starts with my or contains SE. So we use a caret to indicate the beginning of a string. So it should start with my or it should contain SE. Again, very easy. Let's execute this query. And we get the customers with IDs 4, 8, and 10. And finally, we want to get the customers whose last names contain B. So let's change the search pattern. We should have a B followed by R or U. Now, there are 2 ways to write this regular expression. We can use square brackets. So we have B followed by R or U. That's one way. The other way is to use a vertical bar. So BR or BU. These are both valid solutions. So I hope you knocked out these exercises. In the next tutorial, I'm going to show you how to get the records with missing values. In this tutorial, I'm going to show you how to look for records that miss an attribute. For example, if we select all the customers in our database, you can see that the customer with ID 5 doesn't have a phone number. So if you look closely here, you can see the value null. Null means the absence of a value. Now let's say we want to search for all the customers who don't have a phone. Perhaps we want to send them an email and say, hey, your phone is missing in our system. So how can we get these customers? That is very easy. We use the isNull operator. So in the where clause, we type out where phone is null. Now let's execute this query. We only get one customer who doesn't have a phone. Now here we can also use the not operator to get the customers who do have a phone. So we change the condition to is not null. Let's execute the query. Now in the query results, every customer does have a phone number. For this exercise, I want you to write a query to get the orders that are not shipped yet. This is a very useful query that is used in a lot of real applications. For example, let's say you're an admin for an online shop. You want to see the orders that are not shipped yet so you can follow them up. So write a query to get these orders. So here we have the orders table. Let's have a quick look at the data in this table. All right. So if you pay close attention, you see some of these orders don't have a shipped date. And these orders also don't have a shipper ID, which is a unique number for identifying the shippers. So any order that misses a value for the ship date or shipper ID is considered an order that is not shipped. So let's go ahead and write a query to get these orders. So back to our query editor, select star from orders where shipped underline date is null. You could also write shipper ID is null. They're both equally correct. So let's execute this query and we should get 5 orders. Orders 1, 3, 4, 6, and 8. In this tutorial, I'm going to show you how to sort data in your SQL queries. So here we have a query to select all the customers from the customers table. If you look at the query result, you can see that our customers are sorted by their ID. So we have customers 1, 2, 3, 4, and so on. This is the default sort column, but we can always change this using the order by clause. But first, let me explain why the customer ID column is the default sort column. So first, I'm going to open up the navigator panel. On the left side, here's the customers table. Now let's click on this middle icon here that looks like a tool. This opens up our customers table in the design mode. So here we can change our columns. We can add new columns or remove existing ones or change their name or order and so on. Now, if you pay close attention, you can see a yellow key just before customer ID. This means that this column is the primary key column for this table. So in relational databases, every table should have a primary key column, and the values in that column should uniquely identify the records in that table. So back to our query window, you can see that the values in this column uniquely identify each customer. So the customer ID column is the primary key column in this table, and that is why when we write a query against this table, our customers are sorted by their ID by default. Now, let me show you how to sort customers by a different column. So here in the order by clause, we type out the name of another column, like first name. Let's execute the query. Now you can see our customers are no longer sorted by their ID. Instead, they're sorted by their first name in ascending order. Now, if you want to reverse the sort order, simply type out DESC, which is short for descending. Now, we are sorting these customers in descending order. Okay, we can also sort data by multiple columns. For example, let's say first we want to sort our customers based on their state, and then within each state, we want to sort them by their first name. So we type out multiple columns here, state and first name. Let's execute the query. Now you can see that the first state we have here is California, followed by Colorado. And now here in Florida, we have 2 customers, and these customers are sorted by their first name. Let's have a close look here. So first we have Amber, and then we have this other customer here. Now we can also use the descending argument anywhere here. For example, we can sort these customers by their state in descending order, and then sort them by their first name in ascending order, or once again, in descending order. So there are various ways we can sort data. Now, one of the differences between MySQL and other database management systems is that in MySQL, we can sort data by any columns, whether that column is in the select clause or not. For example, let's say we only want to select the first and last name for each customer. Now we can sort the result by any columns in this table. They don't have to be first name and last name. For example, we can sort them by their birth date. Take a look. So this is a valid query in MySQL, but other database management systems sometimes yell at you when you write a query like this. Now we can also sort data by an alias. For example, here in our select clause, let's add the number 10 and give it an alias as, let's say, points. So points is not a valid column in this table. It's simply an alias for an expression. In this case, a simple number. Now here we could have a complex mathematical expression. It doesn't really matter. We can still sort data by an alias. So we can order by points and then first name. Once again, this is a valid query from MySQL's point of view. Now, one last thing before we finish this tutorial. I've seen some tutorials that teach you how to sort data by column positions. For example, here we can order by 1 and 2, and that basically means sort the data by the first name and then the last name. So these are the order of these columns. If we execute this query, you can see that our customers are sorted by their first name and then the last name. While this approach works, it's something that you should avoid, because if in the future you come back here and add a new column in front of the first name column, let's say birth date. Now our customers are no longer sorted in the previous order. So sorting data by column positions produces unexpected results and is something that you should avoid. Instead, always sort by column names like first name. All right, here's your exercise for this tutorial. In this database, we have this table called order items, where we can find the items for each order. Now, I've written a query that you cannot see here because that's the solution to the exercise I'm going to give you. That query produces this result. So we only have the items for the order with ID 2, and we have sorted these items based on the total price for each item. So the total price for each item equals quantity times unit price. In this case, the total price for product 1 is just over $18. So go ahead and write a query to select all the items for order with ID 2 and sort them by their total price in descending order. All right, let's select everything from order items where order ID equals 2. That returns all the items for this order. Now we want to make sure to sort them by their total price. So here in order by clause, we write an expression, quantity times unit price. This returns the total price for each item. And then we add the descending argument here. So once again, the expression that we use in the order by clause doesn't have to be a column name. It can be an alias or an arithmetic expression like this. Let's go ahead and execute this query. This is what we get. Now for clarity, I would like to add another column in the result. So let's say quantity times unit underline price. We give it an alias like total price. Let's execute the query. We can clearly see that this data is sorted by the total price in descending order. However, there is a bit of duplication in our query. We have repeated this expression in 2 places. So now we can simplify our order by clause by using an alias, that is total price. And we get the exact same result. Next, I'm going to show you how to limit the number of records returned from your queries. In this tutorial, I'm going to show you how to limit the number of records returned from your query. For example, when we execute this query, we get all the customers in the customer table. So we have 10 customers here. Now, what if we only want to get the first 3 customers? That's where we use the limit clause. Let me show you. So after from, we type out limit 3, and this will return only the first 3 customers. Now, if the argument that we pass here is greater than the number of records that our query produces, we'll get all the records in the query result. For example, if I pass 300 here, obviously we don't have 300 customers in this table. So when we execute this query, we'll get all the 10 customers in this table. So this is how the limit clause works. Now here we can optionally supply an offset, and this is very useful in situations where we want to paginate the data. For example, let's say we have a website, and on this website we have a web page for the user to see all the customers in the database. Now for simplicity, let's imagine we want to show only 3 customers per page. So what are the customers that we're going to have on page 1? We're going to have customers 1, 2, 3. On page 2, we're going to have customers 4, 5, 6. And on page 3, we're going to have customers 7, 8, 9. Now, let's say we want to write a query to retrieve the customers on page 3. How can we do that? Well, we want to skip the first 6 records and then pick 3 records, right? So we change our limit clause to something like this. Limit 6 and 3. So 6 is what we call an offset, and that basically tells MySQL to skip the first 6 records and then pick 3 records. Let's execute this query. All right, now we get customers 7, 8, and 9. Now, for your exercise, I want you to get the top 3 loyal customers. These are the customers that have more points than everyone else. All right, first we select everything from the customers table. Now we need to order these customers by their points in descending order. So if you look at the query result, you can see that customers are sorted by their loyalty. So the most loyal customers come first. Now we want to pick only the first 3 customers. And that's where we use the limit clause. So limit 3. Let's execute this query. And these are the most loyal customers, customers with IDs 5, 6, and 3. Now, here's one thing I want you to remember, and that is the order of the limit clause. The limit clause should always come at the end. So first we have the select clause, then we have from, optionally we can have where, followed by order by, and finally limit. The order of these clauses matters. If you change the order, MySQL is going to yell at you. So pay attention to the order when writing your queries. So far, we have only selected columns from a single table. But in the real world, we quite often select columns from multiple tables. And that's what I'm going to show you over the next few tutorials. So on the left side, if you look at our orders table, let's select all the data here. In this table, we're using the customer ID column to identify the customer that has placed each order. Now, as I told you before, we don't store customers' information here, like their phone number, their email, their address, because this information can change in the future. And if a given customer has placed multiple orders, then we'll have to come back and change multiple records. We don't want to do that. That's why we have separate tables for customers and orders. Now, in this tutorial, I'm going to show you how to select the orders in the orders table, but instead of showing the customer ID, show the full name for each customer. So let's go back to our query window. All right, so we want to select everything from the orders table. Now we should combine the columns in this table with the columns in the customers table. That is where we use the join keyword. Now here we can optionally type inner join, because in SQL we have 2 types of join, inner join and outer join. We'll look at outer joins later in this section. So for now, we're only using an inner join, and this inner keyword is actually optional, so we don't have to type it. So we want to join the orders table with the customers table. Now, on what basis do we want to join these tables? Well, here in the customers table, we have this customer ID column. So if we put these 2 tables next to each other, we want to line up the records such that the customer IDs are equal. That is where we use the on phrase. So after on, we type out a condition. Here's the condition we need to type out. Orders.customer_ID should be equal to customers.customer ID. Now, this is getting outside of the screen, so let me break up this line. That's better. So with this query, we are telling MySQL that, hey, whenever you're joining the orders table with the customers table, make sure that the customer ID column in the orders table equals the customer ID column in the customers table. Now let's execute this query. Look at the result. Since we're selecting everything here, the first few columns are from the orders table because we have listed that first. Now, after all the columns in the orders table, we have the columns in the customer table. So customer ID, first name, last name, and so on. Now let's simplify the result set and select only order ID, first name, and last name. So back to our query, we select order ID, first name, and last name. Now let's execute the query. That is better. So next to each order ID, we can see the name of the customer that placed that order. Now, what if we want to display the customer ID here as well? Well, let's put that here and see what happens. Customer ID. Execute the query. We get an error. So if you look at the output window, down the bottom, you should see an error saying column customer ID in the field list is ambiguous. Now, unfortunately, I cannot show you this error because the size of my recording window is smaller than MySQL Workbench. But that aside, let me explain why we're getting this error. Because we have this customer ID column in both the orders and customers tables. So MySQL is not sure which table do we want to select this column from. That is why it's saying this column is ambiguous. So we need to qualify this column by prefixing it with a table name. We can either pick it from the orders table or the customers table. It doesn't really matter because the values are equal, right? So in situations where you have the same column in multiple tables, you need to qualify them by prefixing them with the name of their table, okay? Now let's execute the query one more time. So there you go. We have order ID, customer ID, and the full name. Beautiful. Now, one more thing before we finish this tutorial. If you pay close attention, we have repeated the word orders in multiple places. We have it here, as well as in the join condition. The same is true about the customers table. We have repeated that here. We can get rid of this repetition and make our code simpler by using an alias. So right after each table, we can give it an alias, O as in short for orders. So by convention, we abbreviate the table's name. Now, wherever we have orders, we should replace that with O. So here in the join condition, we replace orders with O, and also one more time in the select clause. There you go. We can also apply an alias for the customers table. We call it C, and then we simplify our join condition like this. So this is how we can join columns from multiple tables. Now, for your exercise, I want you to look at the order items table. So in this table, we have these columns: order ID, product ID, quantity, and unit price. Now, I want you to write a query and join this table with the products table. So for each order, return both the product ID as well as its name, followed by the quantity and the unit price from the order items table. And by the way, make sure to use an alias to simplify your code. All right, first, let's select everything from the order items table and then join it with the products table. How are we going to join these tables? On order underline items dot, well, actually, let's just give this an alias right away. So we use OI as an abbreviation for order items and P as in short for products. So OI dot product ID should be equal to P or products dot product ID. And by the way, remember that when you give an alias to a table, you have to use that alias everywhere else. So here I cannot type out products. MySQL is going to yell at me. So let's use the abbreviation. All right, this is how we join these tables. Let's execute this query up to this point. All right, so we see all the items from the order items table, followed by the columns from the products table. Now, we want to explicitly select a few columns here. So from the order items table, we want to select order underline ID. Well, technically, we don't have to prefix this with the table name because this column is not repeated in multiple places. So it's not ambiguous. So let's make the code shorter. That's better. Now we want to select the product ID column. But because this column exists in both tables, we have to prefix it with a table name. either OI or P. It doesn't really matter. Next, we want to select quantity and finally unit price. Now, actually here we have this unit price column in both tables. So this is the unit price in order items table, and this is the unit price in the products table. Now, you might be curious why we have this column in two places. The reason for this is that the price of products can change. So for each order item, we want to have the price at the time the user or the customer placed the order. So this is a snapshot of the price at a given point in time. The unit price that we have in the products table is the current price right now. This is very important for reporting, otherwise we cannot calculate the sales properly. So because we have the unit price column in two places, in this case, we should pick it from the order items table because this is the price at the time of placing the order. Now let's execute the query. So here's the final result. In the real world, when you work as a developer or a database administrator, quite often you will have to work with multiple databases. In this tutorial, I'm going to show you how to combine columns from tables across multiple databases. That's pretty easy. So in the SQL Store database, we have these tables that you're fairly familiar with. Now imagine this products table was not here. Now, if you look at the SQL inventory database, you can see here we have another products table. This products table is exactly the same as the products table that we have in the SQL Store database. So it has the same columns and the same data. Now, technically, this is not a good design. You don't want to have the same table repeated in multiple places. But for this demo, let's just imagine that we don't have the products table here. So we want to join the order items table with the products table in the SQL inventory database. Let's get started. So select everything from the order items table. Let's give it an alias straight away. We want to join this with the products table. This products table is part of the SQL inventory database. So we'll have to prefix this with the name of its database. So we type out SQL inventory dot. Now, once again, we can give this an alias like P, then type out our join condition. So OI dot product ID should be the same as P dot product ID. Let's run the query. There you go. So we successfully joined tables across multiple databases. Now, note that we're prefixing the products table with the name of its database because the current database that we